All right. Hello, Go Matters, and hello to my students. My previous video, let's get focused here. Wait for it. There it is. All right, on my previous video, I talked about how our unit is going to be all about ratios. Now, that was kind of our big picture. Now, there's also steps to get to ratios, so our first lesson is actually all about greatest common factor and least common multiple. Sorry about the focusing here. Here it goes. All right, so we're going to review greatest common factor. Now, you have probably learned this before in previous grades, like 4th and 5th, but so some of us may need a refresher, especially since it's our first week back and we've been off all summer. So let's talk about greatest common factor. Some key words. Greatest meaning the biggest. And again, factor, we're not talking about factors, we're actually talking about what is it divisible by, or you might hear it called the greatest common divisor. So these are all similar terms that you may hear. You may hear as a GCF, you may hear as a GCD for greatest common divisor. Okay, we're talking about all of the same things. So I have two main strategies that I'm going to review with you guys in class and right now. So we're going to start off with an example. Let's say we have the numbers 12 and 8. Okay, and I want to know what is the GCF of 12 and 8. Well, I can use one strategy of listing. And when I'm listing the factors, now again, key is factors, because in a minute we're going to be talking about the LCM, or least common multiple, and they use very similar strategies, but they're used in different ways. So when I'm listing the factors, I'm talking about what numbers can be divided into 12. So I know 1 can go into 12. I know 2 can go into 12 because 2 times 6. 3 can go into it because 3 times 4. So obviously if there's 3, we also need the 4. 6 can go into 12 because 6 times 2. And then of course 12 itself. Okay. Once I've listed my factors, I know that I am done. So now I'm going to move over to my 8. And again, 1 can go into 8, 1 times 8. 2 can go into 8 because 2 times 4. 3 cannot go into 8, not evenly. So another key thing is when we're talking about factoring, we can't have any remainders. Okay, so 3 doesn't work. 4 can go into 8, 5 cannot, 6 cannot, 7 cannot, and of course 8 itself can go into it. So now I have my list here of factors, so I know what is the biggest or the largest number that goes into both 12 and 8. So obviously 1 can go into them, but that's not the biggest number. They have 2's in commons. 12 has 3, 8 does not. 4s are in both 12 and 8, and I said anything after 8 is just 8, and 8 cannot go to 12. So my greatest common factor, or my GCF, would equal 4, because that's the biggest number that both 12 and 8 can be divided by. Okay, so that's one strategy, that's listing our factors. Okay, the other strategy for our GCF, let's refocus here. There it goes. So again, talking about GCF, still looking at the example of 12 and 8. So we looked at listing as one strategy. Now the old school strategy is factoring trees, or you can use a factor tree. Okay, we call it that because we start to make it look like a Christmas tree. We separate them and say, okay, what two numbers when multiplied together will give me 12? So first thing that comes to my mind is always 6 and 2. Now when you're doing a factor tree, you want to make sure that you factor out all the way to prime numbers. Now prime numbers, if you forgot, it's numbers that are only divisible by itself and 1. So 2 is the only factor of 2, it's 2 and 1. 6, however, though, can be broken down into 2 times 3. Again, I have a prime number of 2, and nothing else can go into 3. So once I have factored all the way out to my prime numbers, I know I am done. And I like to circle my numbers when I reach those prime numbers, and then I like to rewrite it as a multiplication sentence. And when I do that, I do it listing my smallest factors first, 2 times 2, and then 3. I always use my dot here to represent multiplication because being that I'm a 6th grade teacher, we're going to soon enter the world of algebra. So I want to make sure that when I am talking about multiplication, I am no longer going to use the classic X to represent multiplication. Instead, I am going to use either my dot or parentheses. Okay, so this means to multiply. Be careful if you're doing this yourself, you're not writing it as too low to make it look like a decimal. Okay, this dot here represents multiplication. So now when I move over to my 8, again, I'm going to factor out things that come to mind are 2 and 4. We know 2 is a prime number, but 4 can be broken down into smaller prime numbers. 2 times 2 equals 4. So again, I'm going to circle those. So now I have 2 times 2 times 2. Okay, so I know 2 times 2 times 2 equals 8. I factored all the way down to my prime numbers. So you think, okay, I am done. Not quite, because remember, we're looking for the greatest number. So now I have to see, what do they have in common? So I see they have one set of 2's in common, and they have another set of 2's in common. I have a 3 here, but not a 3 on this side. I have a 2 here, but not another 2 on this side. So I know I have 2 2's in common. So 2 times 2 equals 4. So this will give me my GCF of 4. Same thing as how we did it with listing. Okay, we still end up with the same answer, but again, it's 2 different strategies. So we have listing our factors and then our factor tree. Now, that is for GCF. Now, on the flip side, we have least common multiple. So when I talk about least common multiple, sorry, brief intermission. I had my cat Butters trying to get in on this video. I don't think Butters would be very helpful for math, but when I talk about least common multiple, focusing in 3, 2, 1. All right, so least common multiple. Now, when you learn greatest common factor, you're also going to learn about least common multiple, usually at the same time. Okay, key words though, least, meaning the smallest, and then multiple. I want you to think the difference. This is multiplication. Okay, so when we talked about GCF, we were talking about division, the greatest divisor. Now this is the opposite. We're talking about multiplication. So I'm going to use the same numbers. I'm going to use numbers 12 and 8, but this time I'm going to use my listing strategy, but I want you to take note of the difference. So again, a listing strategy. I have 12. I'm going to use my colon here, and I'm going to list all the multiples of 12. So for example, 12 times 1 is 12. 12 times 2, 24. 12 times 3 is 36. Okay. Notice these are not factors, these are multiples. I'm saying 12 times 1, 12 times 2, 12 times 3. I am listing all of my multiples. I'm going to do the same strategy for the number 8. So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. And 8 times 4 is 32. I could stop there because I have found 2 numbers in common, or correction, 1 number in common between the 2 of them, and that is going to be 24. Again, I don't want to go on because I'm looking for the smallest multiple. So I can abbreviate least common multiple as the LCM would equal 24 for the examples of 12 and 8. So again, same strategies we use in greatest common factor, but now we're looking at the multiples. I can also use the factor trees for least common multiples, but again, it's going to look slightly different. When I use my factor trees for least common multiples, so I'm talking about LCM, I'm going to still have the same numbers, 12 and 8. I'm going to factor them out, again, using the same numbers I used before. I'm going to factor all the way out until I have just prime numbers. Again, I like to circle my prime numbers to know that I am done. I'm going to list them again as 2 times 2 times 3 and 2 times 2 times 2. Okay, now when I list them, and I'm talking about the LCM, and sometimes you may see it almost as like an ordered pair, saying 12 and 8. What is the LCM? Well, we know that they have to have essentially like the same ingredients. We have to include the same numbers to get the LCM. But I'm not simply going to just say, okay, multiply straight across, and that's my LCM. Instead, I'm going to start with my 12 and say, okay, it has to have a 2 and a 2 and a 3. Then I'm going to come over and look at my 8. I need a 2. Well, here's my 2 there, so that works. They need a second 2, that's there. They also need a third 2. I don't have a third 2 here, so I'm going to add that here. And by adding, I'm meaning that I'm going to multiply another 2. Now that I have all the same ingredients, the same numbers, I can multiply across and say 2 times 2 times 3 times 2 is going to equal 24. So how did I get that? Here are my ingredients of 2 times 2 times 3. That was my 12. I added this extra 2 because I needed it with my factors of 8. So again, I still get an LCM of 24, just how I did it in my listing strategy. But again, this is just another way. So our very first lesson, as we are getting to the unit of ratios and rates, we're going to be talking about the GCF, or the greatest common factor. And we have the 2 strategies there of listing the factors as well as our factor tree. And then we're talking about the least common multiple. Again, using the same listing strategy, but this time we're listing the multiples. Or you can use a factor tree, but we're seeing what do we have in common and making sure we're including all of our numbers to get 24. Okay, so that's a little review on greatest common factor and least common multiple. I'll see you in class to show you more again, but feel free to check it out, like the video, subscribe to our Go Mad for Learning channel. See you in class.